So welcome to Arcade and ArcGIS Dashboards. My name is Subin.
And my name is Shakti.
And thanks for joining us today. So this is an intermediate session, so we assume you know a little bit about Arcade and may have used it in other parts of the ArcGIS platform, or maybe you have a lot of experience with ArcGIS dashboards and are looking to incorporate Arcade in your dashboards. Either way, you're in the right place. Today we'll start off by talking about what is Arcade and how you can leverage Arcade in dashboards. We'll also get our hands dirty by looking at some live demos and wrap up with some best practices and tips and tricks. Before we dive in, any data or dashboard that we're going to be presenting today is for demo purposes only and are not official. And the slide deck that you're looking at will be shared through a link at the end of the presentation. And we're also going to be sharing the links to the dashboards that we will be demoing as well. So with that, let's get started. What is Arcade? Arcade is a lightweight and portable expression language that is used across the ArcGIS apps to do things like formatting pop-ups, formatting labels, styling map symbols, and more. Similarly, Arcade can also be used in ArcGIS dashboards. It enables you as authors to process data on the fly and format or control how data is visualized. Dashboards already provides a host of out-of-the-box configurations options, but Arcade lets you kind of take dashboard to the next level and work around any data-related or formatting-related limitations. In ArcGIS dashboards, there are two main profiles, which the Arcade expression may be evaluated or interpreted. And that's going to be data expressions and advanced formatting expressions. Data expressions are used in all data-driven elements. Using Arcade, authors can construct data sets on the fly or reconstruct them, especially when faced with limitations like data not keeping up with evolving business practices, or you as owners of dashboards but not having control over the original data set, or simply having data captured in two or more data sets. In data expressions, you can access existing data sets using the feature set by portal item function. And this is going to be the most important line of code you write in your data expression, because this is how you're going to access existing layers in an organization or that is stored publicly. And at the end of every data expression, you will return a feature set. And that feature set can be used as a layer or data source to power your visualization in a dashboard. Once you have a data expression, you can use that for multiple elements within a single dashboard. All data expressions are executed in dashboard time zone. And data expressions, we currently support core geometry and data access bundles as of today. Next, we have advanced formatting expressions. Advanced formatting expressions are used to format elements such as indicators, lists, and tables. Formatting expressions are specific to each element, unlike data expressions that can be shared across multiple elements within a dashboard. You can use profile variables or global variables and pass input values that are specific to your data set. For example, in a list or a table, you can pass a $ data point profile variable in your expression to directly use a feature's attribute value for any additional customization or calculation that you might want to do. Like data expressions, all formatting expressions are also executed in dashboard time zone. And today, core function bundle is supported for advanced formatting expressions. So in a nutshell, data expressions return a feature set to power dashboard elements as data sources. And advanced formatting expressions return a dictionary of properties and attributes to control how data is visualized in dashboards. So now that we've covered the basics, we're going to dive into demo 3 different dashboards. And each one will use Arcade data expressions and advanced formatting expressions at varying levels. And our goal is to demonstrate how, with just a couple lines of code, you can improve your dashboards. And for that, I'm going to hand it over to Shakti.
Well, thank you, Subin. Before we get into how Arcade expressions can help enhance our dashboard elements, I'd like to make a quick note. As Subin mentioned in the beginning, none of these dashboards that we will be demonstrating today are real, and they're just created for demo purposes. And yes, what you're currently seeing on the screen is a splash screen feature in dashboards. This was introduced with a recent update to ArcGIS Online that was rolled out a couple of weeks ago. So in this info window here, we have provided a link for you to duplicate this dashboard. You can simply follow this link and create a copy on your end and explore all of the expressions that we will be demonstrating today. So let's get started. A quick introduction to this dashboard. This is a monthly review dashboard for flight delay analysis at the MSP Minneapolis Airport. As you can see here, that there are a lot of indicators at the top showing key performance metrics of the airport, such as total flights that arrived and departed, and number of on-time flights versus delayed flights by both arrival and departure. Also, number of flights canceled versus diverted by both arrival and departure times. And on the right, we have airlines performance metrics, such as a chart visualizing number of flights operated by each airline, and another chart at the bottom showing number of flights delayed by each airline. Additionally, we have a table that's stacked behind, showing different delay causes and the average delay by each airline in minutes. Over here, we have a time series chart that's showing daily flight traffic for both arrival and departure at the airport for the month of November in 2023. Also in the map, the state polygons are symbolized based on the flight traffic to and from the airport. So for the most part, this dashboard is looking good and showing some relevant metrics at a glance. However, this dashboard can still be improved. For example, let's take a look at this time series chart and look at what we are actually visualizing and how this can be improved. Instead of visualizing by number of flights per day, because that's kind of repetitive, I can filter by the flight date and see the total in my indicator. Rather, we can enhance this one to analyze when delays are most likely to occur during the week, and we could also compare it with on-time performance. But I don't have that information readily available to use in my dashboard. So this is when data expressions come into the picture and help us process and model our data on the fly. So we're going to change the data source for this chart and create a new data expression. Before I do that, I'd like to point out a quick update to dashboards. That is, dashboards now allow us to control how date and time values are visualized within the app. You can either let the app to use device time zone or specify a particular time zone. So for this example, I have set it to America, Chicago, because the MSP airport is at Central Time Zone. Now, back to the chart. Let's go ahead and change the data source to a new data expression. And for the time's sake, I'm going to copy paste my code and walk us through step by step. The essential part of writing any data expression involves 3 steps. The first step is accessing the layer of interest using feature set by portal item function. And the input parameter for this function is going to be portal, which can either be an ArcGIS Online or an enterprise portal. Then we have service item ID and the corresponding sub-layer ID. Additionally, we can also specify the set of fields that we want to work with in an array format. Lastly, we have a Boolean parameter that represents whether to fetch geometry or not. So for this expression, I don't have to deal with any spatial information, so I set it to false. Also, I'm further refining my data using filter function to only retrieve records, flight records that either arrived or departed from the MSP airport. The next, second step would be building a dictionary for our new feature set. This dictionary will hold the schema information for our new feature set, such as like fields that we want. So for here in this example, I have like number of flights on time, number of flights delayed by both arrival and departure. Also a separate field to capture day of week value. And as for geometry type, since I'm not gonna work with spatial information, I've set it to Esri geometry null. This will treat this new feature set as a standalone table. For features, I have created an empty array because we're going to calculate the attributes in the next step and update this features array. So what I'm doing here is that for each flight record in my feature layer, I'm first creating a bunch of number variables for both on time and delay. Then I'm calculating the delay difference in minutes for both arrival and departure. If the delay values are negative or equal 0, meaning either flights arrived or departed on time or arrived or departed earlier, then I'm setting the corresponding number variable to 1. Similarly, to identify flights that are delayed, that is when the delay values are positive, I'm setting the corresponding number variable to 1. Additionally, here I'm also changing the time zone of my flight date because the date values are not stored in a way to align with my dashboard time zone, which is America, Chicago. So I'm changing it to a time zone where the UTC has 0 offset, which is Africa, Abidjan. This is just to avoid any shift in dates. And finally, I'm updating my features array with the calculated attributes. And as for day of week value, I'm using the ISO weekday function, which takes the date value as an input parameter and returns any value between 1 and 7, where 1 represents Monday and 7 represents Sunday. And as a final step, we will need to convert our output dictionary as a feature set because the data expression expects the output to be a feature set. As an additional step here, I'm also grouping my new feature set by day of week value so that I can get the sum statistic for total flights on time and flights delayed. Let's go ahead and use this one to power our chart. Since we have already grouped there by day of week, I'm going to create a feature-based chart and keep the day of week as category field and add 2 series, one for on time and one for delayed flights. Now, we can see that in general, Wednesday and Thursday have more flight traffic than the rest of the week. However, irrespective of the traffic volume, the ratio between on time versus delay performance appear to be similar on almost every day of the week. Now let's take a look at the airline's performance metric. This would be beneficial if we can calculate the average amount of time each airline flights are delayed upon both arrival and departure, rather than just simply saying the number of flights delayed by each airline, because that is also kind of redundant. I can filter by the airline and see the flights delayed count on my indicator. Here as well, we're going to write another data expression. Create new data expression. And this expression is going to be similar to the previous one, so I'm just going to skim through the steps. As we saw before, the first step would be accessing the feature layer using feature set by portal item function. And then next, creating a dictionary for a new feature set with set of fields that we need. And again, for geometry type, I've set it to Esri geometry null because I'm not going to work with any spatial information here. The calculations are also going to be similar to the previous one. We would first calculate the delay differences, and then when the values are positive, I would update the corresponding number variable. And finally, updating my features array with the calculated attributes. Again, here we are converting our dictionary to a feature set using feature set function. The only difference here is that unlike the previous expression, we're going to be grouping by airlines and getting the average statistics for arrival delay and the departure delay. Let's go ahead and use this one as a data source. Here as well, since we have already grouped, we can create a features-based chart and add 2 series. Okay, I think now that we have processed our data enough and provided additional insights into the number and updated our elements accordingly. But this dashboard can still be improved visually. For example, if we take a look at these indicators, although they represent relevant numbers, they are not visually appealing. And it would be nice if we could aggregate the total value and rather than just visualizing by arrival and departure. That takes up more space. So all my indicators are filtered in a similar way to show the departure value in the main statistics and arrival value in the reference statistics. Let's go ahead and enable advanced formatting under the indicator tab. We delete the existing one. Here we're first going to calculate the total value by simply summing up the data point statistics and the reference statistics, that is both arrival and departure value. Also, to maintain the ratio between arrival and departure, we're going to calculate the percentage value for each. We can have HTML tags inside the editor itself. So I have created a function here because I need to use the same set of HTML tags to format both my percentage values. Then returning my formatted percentage values as inside another div block and returning that as a final variable down in my dictionary. And also passing the total value that we calculated in the first step as a middle text. Let's go ahead and use this HTML attribute in our description section. So another update to dashboards this February is dynamic text inclusion. So in text editor itself, you can find any custom attributes that are returned from the formatting expressions or any app-related info such as locale or time zone, as well as dashboard item details such as the item title or views or like owner, etc., can be added directly into your text editor. I'm now going to add the custom attribute, and that would look something like this. Now, the indicator is not only visually appealing, but provides additional insight to the number. The same script can be used across all the indicators because, as I mentioned, all of them are filtered in a similar way. After I apply all the same code to all the indicator, my dashboard would look something like this. Now, let's take a look at this table element. It's hard to notice which airline have the highest average value. We can again take advantage of advanced formatting within the table element. Here, we're going to update the background color of the cells. Also, we can use icons to call out the highest value. I have declared a function here because we need to update the background color for each column in the table, and used when function to categorize my values and returned sequential colors based on the average value. And as I said, similarly, we can also have an icon to call out the highest value. But for that, we first have to add an icon down in the icon section. Just gonna pick one, and I'm gonna name it as I. In the editor, I have another function to update my icon that returns the icon that I created when the values are greater than 30. Finally, from the return dictionary itself, we can call the respective functions to update background color and the icon. Now we can see that easily that the Delta Airlines and the SkyWest Airlines have highest average value due to carrier delay reasons. That's pretty much it that I've got. To summarize, we have seen how to write data expressions and formatting expressions within indicators and table element. We could also write formatting expressions within the list element as well. Subin has got some good examples for that. So let's see what she has to show us. Over to you, Subin.
Thanks, Shakti. Some great examples. So yeah, I have two dashboards I'll be demoing. This first one is a status dashboard that is showing 311 requests submitted in the last 90 days in Oakland. Starting from the top left, we have a series of indicators showing how many requests are unresolved, and of those, how many are open, pending, have work orders created, or require more information from customers. And at the bottom, we have request distribution by request source. And we also can see request trends over time, spanning the same time period, 90 days. And over on the right, you can see the request volume by category. And you can see illegal dumping is the most popular, followed by abandoned vehicles. And at the bottom is a feed list of all the requests. So just looking at this dashboard, I think it looks pretty okay, but there are definitely rooms for improvements in some of the way the information is visualized. For example, what kind of bugs me is this pie chart at the bottom. Not only because the colors are kind of distracting, but the data itself could also use some cleanup and consolidation. So first, pop quiz for the audience. What expression would be most suitable for dealing with cleaning up data from an existing layer? Yes, I'm hearing data expressions, and that's exactly right. I want to consolidate some of these source category values and simplify them. So I want to consolidate phone and email into phone or email. And I also want to consolidate the city employee other value with the existing other category. So let's take this pie chart and see what we can do with data expressions. I'm going to go change the data source, which originally it was using the maps operational layer. And I'm going to replace that with a data expression. And let's call it data cleanup. So first off, as always, I want to access my 311 feature layer. So I'm using the feature set by portal item function. And then next, since I'm only concerned with last 90 days worth of data. I am using the Arcade date add function to figure out what day it was 90 days ago, and then using the Arcade filter function and passing that date value as a filter condition. And that will help drill my feature set down, so it helps speed up processing. Now that I have a filtered down feature set, what I will do is for each feature or request in this case, I want to use the Arcade decode function, which works just like a switch case statement. So I want to see what the source is for each request, and if it's phone, I want to return phone or email. And if it's city employee other, then I want to return other. And then at the end of that decode operation, I'm creating a feature object where I'm passing the source value in the source attribute, among other attributes. And at the end, I'm using the Arcade push function to add that feature into an array of features. And in line 16, I declared an empty features array for this purpose. But as we mentioned, all data expressions need to return a feature set, not an array of features. So what I'm doing at the end here is constructing an empty output dictionary. And this is where I'm defining the schema, like the field name, the field type, the geometry type. And for features, I'm passing that features array. And at the end, I'm using the Arcade feature set function to return the dictionary as cast as a feature set. So I'm letting that run. And now we're using that data expression as a data source, and we can reconfigure the pie charts based on the source category. And you can see that now we have a much simpler and cleaned up version of what we saw before. But on second thought, I'm looking at this pie, and I personally don't think that the pie itself is adding that much value in this dashboard. So I actually want to simplify this visual even more and just convert it into a tabular format. And to do that, you can simply add a table element, and the expression that you wrote is now available in the list of data sources. So you can select that and create an aggregated table based on, again, the source category, and simply return a count of requests. And I want to quickly just call this request volume. And there you go. So this is just one of many ways you can process an original layer to suit your unique needs and purposes. So now that that's done, let's see how else I can improve this dashboard. Let's take a look at this list, for example. It's a pretty informative list. It's showing what request got submitted, where it was reported, when it was reported, and its current status. But I kind of want to spice this up so that it not only looks good, but so that it's also able to communicate this information in a more digestible way to viewers. So, second pop quiz, what expression would you use in this scenario? Yep. I hear advanced formatting. Do we all agree? All right. Yeah, so this is where advanced formatting will come in. What I can do is add some color to quickly communicate status and some icons so the viewers can quickly tell what they're looking at with each piece of this information. So from the config, I'll go to the List tab, and under List Options, enable Advanced Formatting. And what that will do is give you a return dictionary of name-value pairs for controlling the different aspects of your list elements. So things like the text color, the background color, the separator color, and so on. I'm going to use my custom advanced formatting expression, where I'm doing a couple of different things. So at the top, I have a custom convert time elapsed function, which I'm using to calculate how many seconds, minutes, hours, days have elapsed since the request was submitted. It's taking in the submit date as the function parameter. And I'm using the arcade date diff function to calculate the difference between now and then in seconds. And then in the next couple of lines here, what I'm doing is just running a bunch of math to calculate and extract how many seconds, minutes, days, hours have elapsed since the request was opened. And at the end, I'm simply returning a formatted string. So a quick tip here. Actually, let's go over this first. You can see that I am storing the formatted string in an arcade variable called time elapsed. And a quick way to test whether your expression is running correctly is simply by just passing the arcade variable in your return dictionary. So I'm just passing it as the custom attribute for now. And as Shakti showed earlier, we can simply reference that in the list item template from this dropdown. And you can see now for each request how long it's been open for. So let's go back up. Another thing that I want to do is notice that we're looking at these like list item icons. And these are essentially map symbols that are color classified by status. I don't really care for the symbols themselves, but I do like the colors because they represent status. But I want to blend that into the list items themselves. And to do that, I am in my expression using the arcade decode function again, to check for the status, and if it's open, then I want to return blue, and then if it's pending, I want to return pink, and so on. And I want to quickly test this too. So I'm storing the decoded results in a variable called status color, and I'll pass that in the return dictionary. Let's do the text color. Now I can see which requests are pending and which are open. So obviously I'm not done here because this looks uglier than before, but I will eventually use these decoded colors in my list items. So bear with me and let's just trust the process. So if we scroll back up, in the next couple of lines, I'm incorporating some hard-coded HTML in the expression itself to really stylize my list and the individual pieces of detail. Oh, notice that these request categories are all caps right now. And I've also, I will be converting that into title cases, and that's a simple arcade proper function. And you can wrap that around your text variables or your strings. And I am storing all of these arcade variables, or storing all of these hard-coded HTMLs into arcade variables. And then storing them in one arcade variable called HTML and passing that in the return attribute. And again, I'll be referencing that in the list item template. So with that, you have a list that quickly communicates status and details of individual requests. And I know that was a lot, but I have a very similar example in the next dashboard. So I can go through some of the other steps in more detail. So this is an informational dashboard that summarizes affordable housing development in LA between 2003 and 2023. Like the last dashboard, this one is summarizing the data spatially based on various attributes and across time. What I'll tackle here again is the project list to enhance it using formatting expressions. Right now, what we have is a bare bone, nothing special kind of project list, and you can click on individual projects to see where it is on the map. Again, I'm going to use advanced formatting here. Here, I'm doing a lot of what I did for the 311 feed. But something that I didn't touch on earlier is that often, rather than hard coding a single block of HTML, it helps to break them down into separate pieces. Like here, I'm separately hard coding some of the HTML styles and storing them in Arcade variables. And I'm almost treating them as custom CSS properties. For example, if I scroll down a bit, I have these HTML properties stored in a variable called nameStyle. And in the line 45 here, I'm referencing that Arcade variable. And I'm using that as this div tags style attribute. And what this will do is style the content of this HTML being the project name. Again, wrapping that with the Arcade proper function so I can title case these projects. Here, I'm also passing this project link icon. And that's a variable that I defined here in the lines just above it. And what that is a hard-coded SVG icon. And that's wrapped with an A tag with an href attribute that is referencing the features project summary URL attribute field. And what that will do is if you, like as a viewer, if you're clicking on the icon, it'll route you to the project summary webpage. Aside from SVGs, you can also return images or attachments. In this specific example, I'll be returning images based on a layer attribute that stores links to a project photo. And I'm referencing that using the global variable and pointing to the photo URL only field. And then in the next couple of lines, I'm also styling the address and a detail section. And at the end, I am storing all of that in a variable, again, called HTML that contains 4 main pieces of information. So the photo of the project name, the project address, and details, including information like construction type, number of project units, and so on. And again, in the list item template, I can simply reference that HTML. So there you go. You have a project list that visually resembles what you're probably more used to seeing on housing property and listing websites. And often using designs or layouts that feel more familiar will help reach a larger audience, navigate information in a more digestible way and also more quickly. So those were just many ways that you could use Arcade to enhance your dashboards. This is just a fraction, a glimpse of what you can do. And I would definitely encourage you to reference our Arcade doc and check out our previous examples from conferences in the past where we have also created dashboard samples to show off Arcade and dashboards. And again, these dashboards will be available online at the end of the presentation. And you can make a copy of them and refer to the expressions and how the elements themselves were configured. So that wraps up the demo. So I'll hand it back to Shakti, who will discuss best practices and tips and tricks.
Thank you, Subin. We hope that now you have an idea of how, when, and where to use Arcade in dashboards. With that, we would like to move on and share a few tips and tricks and best practices to keep in mind when working with Arcade expressions in dashboard. First thing first, performance considerations. Reduce your dataset size as much as possible. Can't stress it enough. Because to improve the performance of your dashboards, it's important to be mindful of how you access your layers data using the feature set function. And it's highly recommended that you only specify the fields that you want to work with your data expression. And also take advantage of filter function to further refine your data and extract features that are necessary for your analysis. Because that's significantly going to reduce the traffic by not pulling everything from your feature service. Another thing to keep in mind is that determining when to query for geometry. Do so only when you are working with the spatial information. Otherwise, simply use Esri geometry null when creating your feature set. That will treat your feature set as a standalone data table. Simplify complex logic and avoid nested queries. Avoid having complex logic on your data expression, because in such scenarios, data expression may end up sending significant number of queries to the backend, like shown in this example, to iterate through all your records in the feature set. This will slow down the execution of your script and can cause performance issues with loading that element and thus the dashboard as well. And you can make use of browser-specific developer tools to keep an eye on your network traffic and also check for any console errors. And you can optimize your expressions as needed. Avoid aggressive refresh intervals. Ensure you set refresh intervals on your data expression only if your underlying data is getting updated. And also make sure you set it to a value that reflects how often your data is going to get updated. And also avoid creating expressions unless it's necessary. Use out-of-the-box configurations when possible. Working with date fields in Arcade. Arcade team has recently added a new data type for dates. This means that when dealing with date fields in data expressions, we no longer have to convert it into epoch by using number function. We can directly access our date fields and work with date values. And ensure you pass correct parameters for date-related functions like date add or date diff, because those require date type as an input parameter. Further, the Arcade team has introduced several date-related functions, such as the date only and time, which will allow you to extract only the time and date component from your date values. Also, a set of time zone-related functions like time zone offset, and change time zone, as we saw in our example, to manipulate any time zone-related information. These functions will be really beneficial in data expression, especially when you're working on a time-sensitive application. In addition to the above set of date-related function, now dashboard also allow you to set dashboard time zone on a dashboard level. Note that both Arcade profiles, data expression and formatting expression, will be executed on the set dashboard time zone. So make sure your dates are aligned to stored in a way that works with the set dashboard time zone. Otherwise, ensure you use time zone related function to modify the time zone information. And also for formatting expressions, it's recommended that you return a string as an attribute. So when working with date fields in your formatting expression, ensure you wrap your date or time value as a text before returning. And that's pretty much it. Okay, when working with other Arcade profiles such as pop-up and visualization, please note that there might be some differences in what is shown on the map viewer versus dashboard. For example, when you are authoring a pop-up Arcade expression, some of the recently added profile variables require interaction with the map itself. So ensure to test it before using it on the pop-up. Also, map symbols using geometry-based expressions or using visualization profile variables such as the $view.scale, those will be ignored at the dashboard level because dashboard list element will not fetch any geometry unless any map actions are configured. This is due to performance reasons and dashboard optimization. So ensure you don't have any expressions like these, like that uses geometry-based functions. To end, we have some additional examples of how Arcade can help enhance our dashboard elements. By leveraging the full potential of it, we can certainly improve our storytelling and communicate complex information in an easily understandable way at a glance. And that's all we've got for today. So over here, the first link is an ArcGIS online group where we have shared both of our demo dashboards and also a list of other blogs and documents that could be helpful to get started. Thank you so much for joining us. I think we're going to open the floor for any questions.
Yep. Got it. So the question was, can you join data or data coming from two different data sets and using data expressions? Yes. You can pull more than one feature layer into your data expression. And if that operation involves a join, then you can do that. There might not be like an explicit Arcade function for joining it, like you would in when you're doing like a field join, but you can do that. Something that we do advise is make sure that the data sets that you're joining are not like super large data sets, because those operations can be taxing and could slow down your dashboard. Yeah.
In Arcade, like, I think get user information.
Sorry, the question was, is there a function for
getting the properties of the user accessing the dashboard?
Oh, interesting. I am not familiar. Oh, so the question was, is there a function for accessing the well, that would be a question for the arcade team.
Yeah.
Yeah, for data expressions, as we mentioned, we support like geometry, core, data access function bundles. If they ever get implemented, then support may or may not bubble up to us, but that would be, yeah, a question for arcade.
Oh, that's good to know.
We have a couple of questions online.
Yep.
So the first question that came in from online, they want to know is there a way to create a custom data set where it's possible to zoom and move the map on data filtered by a category selector that uses grouped data? It's a mouthful.
So I'm assuming that's from a data set, from a data expression.
Yeah.
Yes.
So yeah, that would be possible if you fetch geometry in your data expression, and in the feature set by portal item, fetch geometry parameter. If you set that to true, then it should be configurable to let you zoom or flash or set up any spatial actions. Although we don't recommend that because of performance reasons.
Yeah.
If it's small, it's probably more doable than if it were a larger data set.
Okay, and I have one other question. It says, can I create a category selector dropdown using a data expression that created a value derived from a column in the map data and then use the derived data to filter the map down?
Yep. You can do that using data expression.
Yep, we have a question. So the question was, there's a function for changing or converting time zone. Is there a similar function for converting units?
I'm not pretty sure. I think we can make use of I'll have to double check it before I say it. Yeah, we can check if there are any functions available on the arcade side that would allow us to convert units. Yeah.
And just to answer some of the folks online, they keep asking for the links and access to dashboard, and that will become available to them after this. So, yeah, thanks.
Right.
So the first
link over there is an ArcGIS online group where we have shared both dashboards there.
Yeah.
You can access it, and also it will be available later.
Okay. Yeah, because they don't see it now, so let's let them know that it will be available.
Yeah, it will be available later for you. Yep. I don't think we have.
Right, I think, is that it? All right, thanks again for joining us.